Hi, we're back once again in the Walker Emissions Control Test Lab. In this program, we're going to look at Step 9 in the proper diagnosis of emissions control problems, checking fuel control and air-to-fuel ratio. To help out in this segment, I've brought in another member of the Walker Emissions Control team, Bill Donovan. Bill, fuel control is a complicated and often misunderstood topic.
Yes, it is. Some technicians believe that a vehicle can run correctly with fuel trims off by as much as 10 or 15% in either direction. This might be okay for drivability, but what they might not realize is that they're affecting vehicle emissions, fuel economy, and could be introducing raw fuel into the catalytic converter. And that's a great way to kill a cat.
So let's start with the basics.
Sure. Fuel control is defined as the balance of the fuel volume in the vehicle's air-fuel mixture either above or below stoichiometric or 14.7 to 1 per gasoline. To maintain this ratio, the powertrain control module receives information from the O2 sensors and increases or decreases the pulse width of the fuel injectors. If the PCM increases the pulse width by 15%, the fuel trim is 15% positive and 15% more fuel than the engine was originally designed to use is being added to the mixture. The problem is that the issue causing the additional fuel requirement can be located in just one cylinder, but all of the cylinders on that bank will receive the additional fuel. Typically, the result is that the other cylinders will be too rich, and the cylinder causing the problem may be too lean, elevating emissions. The opposite happens when the PCM senses a rich condition. It will reduce the amount of fuel through negative fuel trims. Ideally, fuel trim should be 0, but we commonly see vehicles operate efficiently on 5% or less. Anything more than that, in conjunction with elevated emissions or reduced converter life, indicates there's a problem somewhere that needs your attention. It's important to think about fuel control in conjunction with the feedback received by the vehicle's oxygen sensors. O2 sensors are effective only when the engine is idling or being operated at a fairly consistent speed. When you suddenly go to wide open throttle, the sensors can't keep up with the increased exhaust flow. As a result, most engine management systems can't effectively monitor and adjust the air-fuel mix to the correct trim. If the fuel trim is already significantly adjusted from 0, the underlying issue may allow unburned fuel to pass through the cylinders and into the exhaust stream. Bottom line, if fuel trims are off plus or minus 8, 10, or 15% to get decent drivability, there's another problem in the engine that needs to be resolved. The running excessively high or low fuel trim could cause the engine to fail an emissions test. It's also important to check both short-term and long-term fuel trims. Long-term trim can be greater than short-term. In fact, it may be compensating as much as 20 to 25% before the mill light illuminates. In order to get an accurate idea of the total amount of trim, you should add together the long and short-term fuel trim numbers. It is important to remember that the goal is to keep the AFR as close to stoichiometric in all cylinders under all RPMs and engine load conditions.
Thanks a lot, Bill, and thank you for watching. Please join us for our next program, which will cover Step 10 of the 13 steps in proper emissions diagnostics. We'll see you then.